So this is the last section of chapter 3. Okay, it's about arithmetic sequences as linear functions. Okay, first of all, what's a linear function that we've been working with? What does a linear function mean? Slope. Okay, what kind of graph is it? It's a graph. What kind of graph?
X and Y.
What does it make? Okay, we use x and y intercepts. What does it make? A line, right? Using slope-intercept form, we've done that. We've also done using x and y intercepts. Okay, so we are going to be dealing with linear functions, but bringing in our arithmetic sequences. Okay, so what is a sequence?
Repetitive numbers.
Okay.
Something that happens in a series of times.
Yeah, happens to a series of numbers. Okay, sequence of events. What comes next? Okay. Terms of a sequence. Self-explanatory. It's just the different things into a sequence. What's an arithmetic sequence, do we think? Think about it. Arithmetic sequence deals with math. Okay? It deals with a sequence of numbers, and we got to see what is the relationship between that sequence of numbers. What's happening between every single term in that sequence. Okay? There's a pattern. What's a pattern? Something that keeps going, right? Going on and on and on, something that's repeated, okay? That's also what common difference means. Common difference is finding that pattern in between two different terms of a sequence, okay? And we're not going to talk about the recursive formula today. That's going to be tomorrow. Okay, so here, we're given different sequences, okay? On this one, we have 3, 5, 7, 9, 11, okay? What they noticed, what was happening in between each one, is they were adding 2. Yeah? So they say D is 2. Okay? In our slope formula, what do you think D can also stand for? In our y equals mx plus b. Slope, right? This can mean the same thing as our slope because it's what's occurring every single time in between every single term or point. Okay? 2, right? So our m would be 2. Okay? Now we can't have negatives, like we could have negative slope. Okay, so from here, they noticed every single time it was going down 4. They were subtracting 4 from every term. Okay, so our m, or our slope, would be negative 4. So when you see the d as they use for common difference, remember we said common difference was like our slope, the slope of what's happening in between every point. Okay, or common difference, think of pattern. What's the pattern in between every sequence? Okay. Any questions over this so far? Okay. Let's look at some examples here. So here, ignore your notes, and up here, I guess. So negative 15, we always start with our first term. Now we go to our next term and see how much was added or how much was subtracted. Okay. We all understand how they got 2?
Yeah.
Okay. Be careful. Are we adding 2 or are we subtracting 2? Adding 2 because we're getting closer and closer to 0. Okay, so what would our slope be in this case? 2. Okay, if I added another term, what would my next term be? Negative 7. What about my next term? Negative 5. We're continuously using that slope that we created, okay, or that we saw. Yeah? So on this one, it already tells you the answer, okay, but let's try and figure out what that common difference is or our pattern. Okay, so always start with your first term. How do we get to the next term? We added 2. Okay, how about this next term? Added 4. What about the next one? Add 2. Is there any pattern going on? Okay, what about our next one? Let's move on. 2. So there's really no consistent pattern, right? We don't have a consistent slope. So linear functions are always going to be consistent. Okay, linear functions always have to have some pattern that is common. Okay, so this one, there is no pattern, so it is not a sequence. Okay, so if there's no slope or no pattern, common difference, whatever you want to call it, it's not a sequence. Okay, let's look at this one. What's happening from our first term to our second term? What are we adding or what are we taking away? We're adding 1/3. Okay, what about from to our next term? We still doing 1/3? Okay, let's keep going. What about this term? Okay. What about here to here? Adding 1/3. Do we all agree we're adding 1/3 every single time?
Yes.
Okay, so is that a sequence? What's our slope? M equals 1/3. Okay, how do we know if it's a sequence or not? Little review. It's consistent with our slope. Every time we move to a new term, it's the same thing. Yeah?
Yeah.
All right. So here we want to find the next 3 terms. Okay, they already told us here that we are subtracting 3 every single time. So let me back up a little bit. What is our slope? -3. Okay, so we need to use that to find our next 3 terms. So starting at -17 and we subtract 3, what do we get? -20. What about next? -23. What's next? -26. Okay, so we use our slope or our common difference to find our next terms. Okay? These, we want to find our next, we're going to keep going. I know it's the same thing. Let's find the next 3. How do we find the next 3? Subtract 3. Use that common difference that's down here. What do we get for our next 3 terms? There you go. Awesome. All right. Are we doing okay?
Yeah.
So, let's find the next 3 terms. In order to find the next 3 terms, what do we have to find first?
We have to find the pattern.
Find the pattern, the slope, common difference, okay? So where do we start?
58.
Start at your first number. How do we get from 58 to 63?
You added 5.
Added 5. Is that the same for the next one?
Yeah.
What about the next one?
Yeah.
Okay. So what would our next term be? 78. What about next? 83. What's next? 88. Awesome. Questions over finding the next 3 terms or finding the common difference? All right. Okay. Any questions?